All right, next up, we're going to talk about kinetic energy and temperature. So remember when we were talking about kinetic molecular theory, we were talking about how when we increase the temperature, we increase the kinetic energy. So let's think KE, kinetic energy. Let's think back to what that was back in our energy chapter. And we said kinetic energy was the energy associated with movement, right? With movement. So water falling down a hill, something like that. And we said that temperature is proportional to kinetic energy. So as temperature increases, what happens to kinetic energy? Right? KE increases. And so they're going faster, but it's a little bit more complex than that. And the complexity comes from the fact that if you're able to zoom in and look at the molecules of a gas at some temperature, they're not all moving at the same speed. They're moving at different speeds. So molecules move at a distribution of speeds. But overall, the average is going to be constant if you're staying at the same temperature. So one molecule might be moving fast 1 second and then slow another, but overall, it's going to be the same, the average. So think back here, if you think up here is number of molecules, and this right here is speed. Looks something like this. So you can think of this as kind of like a probability chart, right? Most molecules are somewhere up here, right? It's got the biggest area under the curve. And then very few are moving very fast or very slow. Most of them are somewhere in the middle. And then just this little like point here is the average. It's not the same average. It's the root means square average. It's a little bit to the right because of this area over here. You can see it's non-zero there, whereas kind of it goes to zero at 0. So again, not all molecules are moving at the same speed. But the temperature is going to be related to the average. So when you're taking the temperature of something, what you're doing is taking the average speed of these molecules. But it's not just the speed, as we'll see in a second. So kinetic energy is related to kind of how fast you're moving or how fast your molecule is moving. So if you think about this kind of question, which one has more kinetic energy? A baseball at 75 miles per hour or 100 miles per hour, right? And you should be able to easily kind of figure out that the thing that's moving faster has more kinetic energy, right? Faster movement, more kinetic energy. But kinetic energy is also related to mass. So think about which one of these has more kinetic energy. So let's say like a truck at 50 miles per hour or a motorcycle. Going the same speed. Think about if they crashed into each other, which one would win out? Which one has the most energy? And it's the truck. It's the truck, right? So faster and more mass is more kinetic energy. The overall equation is kinetic energy is equal to 1/2 times the mass times the symbol right here, mu. It's called the velocity, right? So this is mass here. And this is the velocity, or the root means average, root mean square average velocity.